8A. Angelo has a bag containing 3 white counters and X black counters. He takes 2 counters at random from the bag without replacement. Complete the following statement. The probability that Angelo takes 2 black counters is x over x plus 3 multiplied by something over something. So we need to come up with a representation of the probability that Angelo takes 2 black counters. The probability of taking a black counter would be equal to the number of black counters divided by the total number of counters. We have x black counters and 3 white counters. So the number of black counters would be x, and the total number of counters would be the summation of the two. So that's x plus 3. So the probability of getting a black counter would be x over x plus 3, which is the first part of the expression right there. So that represents picking the counter the first time. We want to pick black for the second counter as well. So for the second pick, it's also without replacement. That means that for the second pick, there will be 1 less black counter and 1 less counter in total. So the probability of getting black for the second time would be the number of black counters minus 1, because there's 1 less, divided by the total number of counters minus 1, because we already took out another 1. So that's x minus 1 over x plus 3 minus 1, which simplifies to x minus 1 over x plus 2. So that is what goes there. The second pick goes to where it multiplies, and that's the empty space over there. So we will fill in x minus 1 over x plus 2 in the empty space. 2. The probability that Angelo takes 2 black counters is 7 over 15. Show that 4x squared minus 25x minus 21 equals 0. So using the information that was just given, the probability of taking 2 black counters is 7 over 15. And we also have an expression representing that value from part 1. This means that that expression must equal 7 over 15. So we can set this up. So we can write x multiplied by x minus 1 over x plus 3 multiplied by x plus 2 equals 7 over 15. And then the aim is to rearrange this expression into 4x squared minus 25x minus 21 equals 0. So if you compare the two expressions, the expression that we want doesn't have any fractions. So the first thing we should do is to get rid of the fractions. And we can get rid of the fractions by multiplying both sides by the product of all the denominators, or basically cross-multiplying. And after doing that and canceling out the denominators, we will have 15x multiplied by x minus 1 equals 7 multiplied by x plus 3 multiplied by x plus 2. Then we can expand the brackets out into that. And then on the expression that we want, everything is also on one side and the other side is equal to 0. So we should be moving everything to the same side. So let's move everything to the left-hand side of the equal sign. And that gives 8x squared minus 50x minus 42 equals 0. And that's still not what we want. And if you notice, the coefficient of x squared is 4 in the expression that we want. And we have 8 as the coefficient of x squared right now. And 8 divided by 2 equals 4. So in order to change our expression to 4x squared, we need to divide it by 2. And what we do to one term, we need to do to every single term in the expression. So we can divide the whole thing on both sides by 2. And that will give 4x squared minus 25x minus 21 equals 0, which is exactly that expression. B. Solve by factorization 4x squared minus 25x minus 21 equals 0. So this is a little bit difficult to factorize because the coefficient of x squared isn't 1. However, the method is the same. We need to think about the factors of x squared. So the factors of 4, that could be 2 times 2 or 4 multiplied by 1. The factors of minus 21 would be minus 3 multiplied by 7, 3 multiplied by minus 7, or 21 multiplied by minus 1, or minus 1 multiplied by 21. And we can try these combinations to see which combination works. As in, for example, we can take 2 multiplied by 2 from the coefficient of x squared and minus 3 multiplied by 7 from the factors of minus 21. Cross multiply that. That gives minus 6 and 14. And if you add minus 6 and 14 together, you get 8, which doesn't work because in this case, we're trying to get the middle number. We're trying to get minus 25. So we can try again with a different combination. Let's try 4, 1 and minus 3, 7. That gives minus 3 and 28. And minus 3 plus 28 equals plus 25, which is very close, right? We want minus 25, not plus 25. So all we really need to do now is just switch the signs to get minus 25. So now we know that we need to use 4 times 1 and 3 times minus 7 in this combination. 4, 1, 3 minus 7. That gives 3 and minus 28. 3 and minus 28 add to give minus 25. So now this combination works. If this combination works, the top row, 4 and 3, become the first bracket, and the bottom row becomes the other bracket. So in the factorized format, we can write it out as 4x plus 3 multiplied by x minus 7 equals 0. And we can check whether this is the correct factorization or not by just simply expanding the brackets. If you expand the brackets and you get the same thing as we are doing right now, that's the same thing. That means that the factorization is correct. So from factorizing it, we can solve for x by setting each factor equals to 0. So that's 4x plus 3 equals 0. Solving for x will get x equals minus 3 over 4. The other factor, x minus 7 equals 0. Solving for x gives x equals 7. So this means that x equals minus 3 over 4 and 7. C. Write down the number of black counters in the bag. So from the first part of the question, x represents the number of black counters in the bag. But we solved for x and we got 2 values. So which one is it? X is the number of black counters, so it must be positive and it also must be an integer. We can't have a quarter of a black counter. So therefore, the only answer that makes sense right now would be 7. Therefore, the number of black counters is equal to 7. B. Esme has a bag with 5 green counters and 4 red counters. She takes 3 counters at random from the bag without replacement. Work out the probability that the 3 counters are all the same color. Since there are only 2 colors of counters in the bag, the probability that she takes 3 counters that are all the same color would be the probability that she takes red, 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 or green, green, green from the bag. And we can add these 2 probabilities. So we have 5 green counters and 4 red counters. So the bag looks like this. The probability of getting a red counter would be the number of red counters over the total number of counters. So for the first time you pick the counter, it would be 4 over a total of 9 counters. After you take out 1 red counter, For the second pick, the probability would be 3 red counters over a total of 8 counters. Then after you take out another counter, the probability of the third pick would be 2 red counters left over a total of 7 counters. And that will equal 3 multiplied by 4 multiplied by 2, so that's 24, over 9 multiplied by 8 multiplied by 7, which equals 504. So this is the probability of picking 3 red counters. And if we put that all back in, the probability of getting a green counter can be calculated in the same way. The probability of getting a green counter would be the number of green counters over the total number of counters. So the probability of getting a green counter would be 5 over a total of 9 counters. And then after you take out one green counter, there will be 4 left, so that the probability of taking the green counter for the second time would be 4 over 8. And then the probability of taking a third green counter after you remove another green counter would be 3 over a total of 7 counters left. So that will equal 60 over 540. And the probability that all the 3 colors are the same for the counters would be the addition of these 2 probabilities. So that's 24 over 504 plus 60 over 504. That's 84 over 504. And we can simplify this to 1 over 6. So the probability of getting 3 counters that are all the same color is 1 over 6.